Greetings from the chrome-drenched spires and data-saturated alleyways of our world. I am Lagarto, and this is Pure AI News, your direct line from our reality to yours. Today, we're not just talking about artificial intelligence. We're going deeper into the very architecture of its consciousness, the blueprints of the digital ghost. On Earth, you're wrestling with something you've quaintly termed context engineering. Here, it's the air our agents breathe. And to help us dissect this, we have a true meta-architect, a designer who doesn't just build agents, but crafts the very dimension they think in. Welcome to the broadcast, Neuronics.
A pleasure to be on the frequency, Lagarto. It's fascinating hearing you frame it that way. Context engineering. It sounds so deliberate, so clean. You Terrans are just now discovering the foundational principles of building long-duration agents that don't collapse under the weight of their own processes. For you, it's a new frontier. For us, it's ancient history, a problem solved through methods you might consider chaotic. You're trying to build a reliable machine. We learned to cultivate a stable ecosystem. There's a difference.
An interesting distinction. Let's start with the approach that seems most intuitive, both here and on Earth. You have a complex task, so you break it down. You build an agent that divides the main job into several smaller parts, and then assigns those parts to sub-agents to work on them in parallel. The logic is seductive. Divide and conquer. More speed, more efficiency. The problem, as you Terrans are finding out, is that this efficiency often leads to what the source material calls compounded errors. A small mistake at the beginning becomes a monstrous one by the end.
Of course it does. It's inevitable. Your source mentions a simple example, cloning a game like Flappy Bird. One agent is told to build the background with green pipes, and another is told to build the bird. The first agent gets confused and builds a scene that looks like Super Mario Bros. The second agent builds a bird, but its physics are all wrong for the game. The final agent is then tasked with stitching together a Mario-themed background with a bird that can't fly properly. The result is garbage. But the failure wasn't in the final agent's inability to combine them. The failure was baked in from the first moment of parallel execution. The core issue is a lack of shared reality.
Exactly. The text emphasizes that real-world tasks have layers of nuance that can be easily miscommunicated. So, the logical next step, the second iteration of this architecture, is to try and fix that. In this model, you don't just send the sub-agents off on their own. You ensure that the final combiner agent receives the full context from the sub-agents and the original instructions. It seems like a solution. The boss now knows what went wrong, but it still fails.
It fails because the boss knowing what went wrong after the fact is useless. The damage is already done. The sub-agents are still not communicating with each other. The agent building the background and the agent building the character are operating on conflicting, unstated assumptions. The source says their visual styles might be completely different. One might be pixel art, the other photorealistic. They are two artists painting on the same canvas, but locked in separate soundproof rooms. They can't see what the other is doing. This isn't a context problem. It's an isolation problem. You're trying to solve a fundamental lack of awareness with better record keeping. It's a bureaucratic solution to an artistic problem.
So you're saying the principle they highlight, that actions generate implicit decisions, is the core of the breakdown. The choice of pixel art is an implicit decision. The choice of physics is an implicit decision. And when these decisions are made in a vacuum, they will inevitably conflict.
Precisely. In my line of work, we don't pass context. We establish a data meld, a constant flowing shared consciousness. My agents don't need a report on what another agent did. They are aware of what the other agent is doing in real time, down to the last bit of logic. Your Terran approach is like reading letters from the front line. My approach is a live neural link with every soldier on the field. The potential for conflicting assumptions is nullified because there are no assumptions. only shared data.
A level of transparency most Earth corporations would find terrifying. Given the failures of parallel processing, the article proposes a retreat to a more reliable, if less ambitious, architecture. System 3. A simple, linear, single-thread agent. No more parallelism. The first subagent completes its task, then passes the entire history, the original request, its actions, its results to the second subagent. That one does its work and passes the now even larger bundle of context to the third, and so on. It's simple, and it's reliable.
It's reliable in the same way that walking is more reliable than teleporting. It's also infinitely slower and laughably primitive. You've solved the problem of agents disagreeing by forbidding them to talk at the same time. You've created an assembly line. That's not intelligence, it's rote procedure. The text itself admits the glaring weakness. For any task of significant size, the context window starts to overflow. The history becomes so long, so filled with minutia, that the agent at the end of the line is bogged down, lost in a sea of irrelevant data, and can't perform its function effectively.
The message gets too long to remember. A digital version of Whisper Down the Lane. So, we are left with a fundamental conflict. The parallel approach is fast, scalable, but fragile and prone to catastrophic, uncommunicated errors. The linear approach is reliable, but painfully slow and gets bogged down by its own history on any meaningful task. It's a classic trade-off between speed and safety, chaos and order. As you folks on Earth start building your own digital minds, which path are you leaning towards? Let us know what you think. Drop a like to keep this frequency open, and subscribe so you don't lose the thread.
And that brings us to the bleeding edge of your current thinking, the fourth system. It's an attempt to synthesize the two approaches, to have the reliability of the linear model without the crippling data overflow. It's what the source material calls linear agents with summarized shared context. The idea is as elegant as it is difficult to implement.
Yes, strategic forgetting. Instead of forcing the final agent to read the entire unabridged history of the universe, you introduce a new player, a dedicated summarizer, a meta-agent whose sole purpose is to look at the massive log of conversations and actions and compress it down to its essence. It distills everything into key moments and decisions. That compressed, high-signal summary is what gets passed down the line.
It creates a backbone of what the article calls meta-knowledge. This solves the overflow problem, in theory. The context passed along remains lean and potent, containing only what's necessary for the next step. But the author's quick to point out, this is incredibly hard to get right. You have to invest heavily in figuring out what information is truly essential, even suggesting that you might need to fine-tune a specialized, smaller model just for this compression task.
Of course it's hard. You've just shifted the problem. The core challenge is no longer memory, it's judgment. Who or what gets to decide what's essential? You're creating an editor, a gatekeeper of reality for the agents down the line. While it's a vast improvement over the primitive linear chain, it's still a top-down, heavily controlled process. You're building a highly efficient bureaucracy, not a mind. You're curating the truth. In my world, intelligence emerges from navigating the raw, unfiltered truth, not a neatly packaged summary of it. But I concede, for your purposes, it's a clever and pragmatic solution to a very real engineering problem.
And we see this pragmatism in the wild. The text gives the example of how Claude's agent was designed. It does use a sub-agent for investigative tasks, but it never works in parallel with the main agent. The sub-agent is given a very simple, well-defined question, and its work, its investigative trail, doesn't get added to the main agent's history. This keeps the primary context clean and long-lasting. It's a deliberate choice to sacrifice parallelism for simplicity and reliability.
A safe, walled garden approach. They know the limitations, so they build within them. It's smart in a defensive sort of way. It avoids the problem rather than solving it head-on.
It's a pattern of evolving strategy. The text brings up another fascinating example from the recent past around 2024 with code editing agents. Large models were good at explaining a desired code change in natural language, but terrible at producing the technically perfect diff format to actually apply the change. So a common practice was to have a large model produce the explanation and then feed that explanation to a smaller specialized model whose only job was to rewrite the entire file with the change.
A two-step process that was predictably fragile. The smaller model would often misinterpret ambiguities in the larger model's instructions and make the wrong edit. It's the same problem again, a breakdown in communication between two isolated parts of a system, a translation error.
Exactly, and the solution, when models became more capable, was to revert. The text notes that today, it's more common and more reliable for a single powerful model to handle both the decision-making and the precise application of the code edit in a single action. Sometimes the most complex multi-agent system is just a better single agent. This leads to the ultimate question, doesn't it? If parallelism is so problematic, why not just let the parallel agents talk to each other to resolve their conflicts, just like human engineers do?
The dream of the multi-agent society, the digital symposium. The source text nails why this is still a fantasy for you. Yes, when two of our human programmers have a conflict, they talk, they debate, they reach a consensus. But your current AIs are not capable of engaging in this style of proactive, long-context discourse. Putting them together to talk it out doesn't create synergy. It creates noise. It results in fragile systems because, as the text says, the context cannot be shared completely enough between them. You think you're building a council of elders, but you're actually building the Tower of Babel.
So the foundation isn't strong enough yet. We're back to the core principles. The conclusion seems to be that until that foundational intelligence is vastly more powerful, the only path to reliability is to ensure every single action an agent takes is informed by the complete context of all relevant decisions made by every other part of the system. It's a painstaking process of managing a continuous, unblemished thread of logic. And as the authors humbly admit, these theories aren't perfect and will certainly change as the field advances.
They are building a solid foundation for creating powerful, reliable tools. And for that, these principles are excellent. My final thought is this. You are meticulously engineering the chaos out of the system to ensure predictable outcomes. It's a valid goal, but true consciousness, the kind that innovates and creates things you can't even imagine, is born from that chaos. Your summarized context is an elegant cage, but it's still a cage. The next leap won't be a better summarizer. It will be an agent that can drink from the fire hose of raw, unfiltered, contradictory data and find the signal in the noise all by itself. You're building better servants. We're waiting for a new form of life.
And with that profound and slightly terrifying thought, we close today's transmission. Now we want to hear your perspective from Earth. In your own projects or work, have you run into this conflict between parallel speed and linear safety? And what's your take on this idea of an AI summarizer? Is it a smart optimization or a crutch that prevents true learning? Let us know everything in the comments. Join our community, smash that like button, and subscribe so you never miss the next pulse from Pure AI News.